Today we're going to discuss the sample triangle. The sample triangle is composed of three different variables. The first one is the confidence interval, which is the error around our measurement. The confidence level is how sure we can be of the results we're seeing in our data tabs. And the third component is our sample size, which consists of how many people we actually surveyed. Let's first talk about our confidence interval. Confidence interval is also sometimes called a sampling error. And really what it is, it's the price you pay for not surveying everybody in your universe. So during our sampling lecture, we talked about how one of the only known samples that actually surveys that attempts to interview the entire universe is our US Census, which is conducted every 10 years. The cost of that is billions and billions of dollars, which is why it's cost prohibitive to sample our universe for everyday research initiatives. So the confidence interval describes the range that the answers would have likely fallen in had we conducted a census instead of just using our sample. So let's take an example. Say we have an ending sample size of 300 for our survey. Because we didn't sample our universe, our error range associated with that sample size is plus or minus 4.7 percentage points. So let's say we asked consumers in that study what proportion of them chewed sugar-free gum in the past week. And say 50% of them told us that they had chewed sugar-free gum in the past week. Then, working with our sample size of 300 and our proportion of 50%, which we see in our study, the true percent that we would have seen in the universe if we had sampled every single person we could have, the results would have been as low as 45.3% or as high as 54.7%. So our error range is the range between 45.3 and 54.7. How you calculate that is you take the proportion of people who said they did something, in this case chew sugar-free gum, and for our low point we'll minus the 4.7 percentage point error range by that 50%. For our high-end range, we'll take the 50% and we'll add it to 4.7, and that's how we calculate our error range. So we know that for this study, our results would have come somewhere between 45% and almost 55%. Now, the confidence interval will change depending on your sample size. So we just discussed an example where we had a sample size of 300 and our error range was 4.7 percentage points. As you increase your sample size, the error range decreases. And that's simply because as you add more and more people, the error range is tighter and tighter because you're interviewing more and more people who are in your sample population. So if we wanted to sample all the way up to 900 consumers, our error range would go down to 2.7 percentage points. Here's a chart that shows what the error range will be at different sample sizes. As you can see, the smallest sample size has the largest error range. So if we were only able to interview 100 consumers, our error range would be plus or minus 10 percentage points, which is fairly large. If you go down to 1,000 consumers, our error range is 3. At 2,500, our error range goes down to 2 percentage points, and at 5,000, we go down to 1 percentage points. So why don't we interview more people rather than less people in our quantitative survey? Well, one, there's a timeliness factor. Most research is done and has a date in which results must be delivered by, because businesses need to make decisions to move their strategic initiatives forward. So sometimes you don't have the luxury of time to sample a bigger base of consumers. The other reason why we don't sample larger sample sizes than necessary is because there's a cost associated with interviewing each and every respondent. So it gets very cost prohibitive very quickly as you move up to large and larger base sizes. You can see the curve here kind of straightens out once you get to about 300 and 400 base size, and that's why that tends to be a robust enough base size for most research initiatives. There are some where you'd want to get more sample rather than less, and there's some studies where less sample is adequate if you're not making a huge decision. But for the most part, 300 and 400 sample size seems to be enough to give us the confidence interval necessary to make most business decisions. The next component that we'll talk about is a confidence level, and that's how sure we are about the results that we're seeing. So let's understand that a little bit further. Confidence levels are expressed as a percentage point, and they represent how often the results we see in our survey will fall within that confidence range if we were to repeat the research. So if we're using a confidence interval, say of 90%, if we conducted our research using the same questionnaire and the same methodology and the same sample size, 9 out of 10 of those surveys we'd be confident would give us the same identical results. If we went to a 95% incidence, you would get the same numbers 95% of the times. Sometimes corporations want to use a 99% confidence interval, and that's when they need to be absolutely certain in the research results. So to give you an example, if your company was going to spend millions and millions of dollars buying a plant and buying new equipment to produce a new product that you'd like to put on the market, you'd want to be absolute certain from our research findings whether or not you make that go or no-go decision. And that's when you would increase your confidence level, because you want to be certain that what you tell senior management would actually be beneficial to the company. So let's take another example. Again, let's use our sample size of 300. And our confidence interval, we know at 300 is 4.7 percentage points plus or minus. So say now we conduct a survey and 50% of our people say that they use mouthwash. So using a 90% confidence level means that I would be 90% confident that the real percentage of people in our universe who say they use mouthwash is 50% plus or minus 4.7 percentage points. So in other words, if I conducted that same research 10 times, I would see those results 9 out of those 10 times, which gives me a confidence interval of 90%. Our last component in the sampling triangle is our sample size, which is how many people we've surveyed. And we've spoken a little bit about that in relation to our confidence interval and our confidence level. Things to keep in mind when doing quantitative research. You really want to stick with a robust base size. The stronger your base size is, or the higher your base size is, the more confident you will be in the results that you're seeing. You never want to, in a quantitative research, analyze a sample size of less than 30 people. That really is considered more qualitative in nature. And if you're citing results among a small group of people, say 30 or less than 30, you'll want to caveat it by saying it's a directional read and not a quantitative read. Minimally, you really want to interview at least 75 respondents, although in research, the generally accepted minimum base size is 100 for subgroup analysis. So when you're designing your research and you're designing your sample frame, you need to make sure that if you need to look at a certain subsegment of the population, say males or females, by gender, you're looking at the results by gender, you really do want to make sure that you could look at each of those with a readable base of at least 100 respondents. So you can see that all three of these work together, and I've put together a little cheat sheet for you that goes into a little bit more information. And I kind of use this every day in my job. When you're talking with clients or when you're designing research, you need to talk to them about these three different measures and how they work together. Say your client says to you, gee, I know you've recommended a base size of 300, but I don't have the money to spend or the time to interview 300 people. So you can use this little cheat sheet to look at and see exactly what would happen. So if we decrease our base sizes, there's three options to consider. If we decrease our base size, we're going to be less confident in the results that we have. And our confidence interval would remain the same. However, if we want to relax the error range while decreasing the sample size, then we can maintain the same confidence level that we had at a more robust base size. Conversely, if we were going to decrease our sample size and we wanted to be less confident about the results, so we're reducing our confidence interval, then we can relax the error range. So all three of these work together, and you can see how one will impact the other depending on the situation that you and your client face.